Morning all, thought I'd say hi, show you where I work. Computer, stolen from college. Play-Doh today, smiley face. Let's crack on with some work. Right, being careful not to turn you off. There we go. Right, that's from another take. Right, I'm going to do this all in one go now. We're going to look at the periodic table now. My decent periodic table online is ptable.com. It's quite good. You can click on things, learn about the different elements. You go on isotopes. If you click on orbitals, it will start to confuse you an awful lot about spin states and things like that. So not bothered about that. Bothered about this. Let's click on carbon, isotopes. Look at all the different types of carbon we can get. Ooh, wonder what different types of hydrogen we can get. Let's backtrack. Before we start doing this? Right, so we know our model of the atom is the Bohr model of the atom, named after Mr. Bohr. Did he have a beard? I don't know, he's not going to tell us. No, he didn't have a beard. He did some quite interesting stuff with opposing Nazi Germany and things. He was a Danish person. Have a nosy into him. They tried to get him to work on the German nuclear weapon program. Anyway, him and Rutherford came up with this model that you know, love and understand. We've got protons and neutrons in the middle. We've got electrons going around the outside. You know this. This is the Bohr model of an atom. You could draw it and you could label it. That would be an amazing thing for you to do. Now, I only care, as physicists, we only care about the middle bit, the electron bit. That's all chemistry. We care about the middle bit. The middle bit with the protons and the neutrons in. Okay, let's have a look at a proton and a neutron. Now we'll get a bit more further in detail of what makes up a proton, what makes up a neutron. We've got three things in an atom. You might remember this. Let's talk about the mass. Relatively, if a proton has a mass of 1, the neutron had a mass of 1, and the electron had a mass, well, we used to say 1 over 2,000, but now we've moved up a gear, we're going to say 1,836. So that means if you could weigh one proton, let's make protons red, and if you could weigh, you would need 1,836 electrons to have the same mass as a proton. Okay? Now I wonder what that is in kilograms. It's obviously very small. You could research that and tell me what the mass of a proton is, the mass of an electron is, the mass of a neutron is. Okay, I like that. That's good. Let's do something different as well. After that, let's look at charge. So the proton has a charge of +1 because it's a positive particle. The electron has a charge of -1 because it's a negative particle. And the neutron has a charge of 0 because it has no overall charge. Now from GCSE physics, you might remember that charge is measured in coulombs. You might remember that because of Q equals I times T. You might remember that. Anyway, charge is in coulombs. If you don't remember, look up your GCSE notes or look up bite size about charge. But what is the charge? Well, charge is 0 minus 1.6 times 10 to the minus 19 coulombs. Again, you can look it up. The proton charge is the same as the electron charge. Quantity-wise, one is positive and one is negative. Let me rephrase that. The electron has a charge of 1.6 times 10 to the minus 19 coulombs. It is negative. Okay? The proton has a positive charge of 1.6 times 10 to the minus 19 coulombs. Okay? And obviously the neutron has a charge of 0. And that's the difference between my relative and my actual table of charge and mass. Okay? Next video we're going to talk about isotopes. And my 5-year-old kid has just decided to come in and hug me. So I'm going to stop and do the next one in a second.